everyone, Lisa here. Just finished watering my deck plants. Now I have to go do the raised beds. Think I'll use the hose for that one. It'll be easier. One time the hose actually split and I had to use the watering can to water these beds. It worked, but it wasn't the most efficient way to water the garden. Glad I have a new hose. It's nice to have the right tool for the job. Sometimes a job takes only one tool, like a hose to water a garden. Other times a job takes many tools, like when a building's being constructed. Monitoring weather and climate, that's the kind of job that takes a lot of tools to do well. Let's take a look at some of those tools. If weather forecasting is your job, there are many tools involved in this. There are automated weather stations that record data about temperature and humidity, air pressure, precipitation, wind, clouds. Some weather stations still use traditional thermometers or rain gauges that people come to read and record from. But most stations these days are automated and use sensors, data loggers, computers, and satellite links to collect, store, and transfer data. If you're a weather forecaster on the coast, land-based data isn't enough to do your job completely. You need ocean data as well, and this is collected from buoys anchored in place in the ocean. They use sensors similar to land-based weather stations, and they collect similar data, but in addition, they collect data about waves. This results in a marine forecast that includes typical weather factors as well as wave heights and wind speed and direction. All of these things are important to those who work at sea or go out for fun. Since the 1960s, we've had satellites in orbit around Earth that are capable of measuring atmospheric conditions. There have been incredible improvements in satellite instruments that have made weather forecasting more accurate and a lot faster. We've gone from simply being able to take pictures of cloud cover to being able to measure the temperature and water vapor content of the air at many different heights above the Earth, all measured from miles away in space. Weather balloons are still launched twice a day, every day at the exact same time from hundreds of locations across the world. These balloons carry radiosondes, which are instruments containing several sensors that take measurements of temperature, pressure, and wind as the balloon rises up through the atmosphere. These measurements are relayed by radio waves to stations on the ground. As you well know, weather and climate are not the same thing. So if you're a climate scientist, what tools do you rely on for your data? With climate, we're interested in trends and patterns in the weather and other conditions over long periods of time, decades and centuries. Fortunately, there are a vast number of weather stations across the world to help collect this data. There are more than 100 years of historical temperature and precipitation data, as well as other climate data, available to scientists. But there's more to climate than knowing what the weather patterns are or were. Interactions between the oceans and the atmosphere are responsible for the various climates across our planet. So if you want to study climate, you need to look to the oceans for data as well. The ocean is huge and absorbs a lot of energy from the sun. The ocean water stores this energy as heat. As the ocean water moves around the globe, the heat goes with it, and some of this heat is exchanged with the atmosphere. So it's important for a climate scientist to know how much heat is in different parts of the ocean and how the ocean waters are moving. Satellites are good at collecting data from the surface of something, and many of our satellites collect data about sea surface temperatures. But satellites can't penetrate the surface of the ocean to get deeper water temperatures. Some weather buoys have sensors below the water taking temperature readings at various depths in the ocean. Other instruments like moored profilers, floats, and other shipboard instruments are also used to collect temperature readings at different depths in the ocean. Some instruments can also measure the speed and direction of ocean currents. Data from the combination of these tools helps scientists understand how heat moves from place to place on Earth, how this impacts the climate in different parts of the world, and what changes may be occurring. You might be wondering why we haven't developed a single weather climate tool that can measure everything we need to know about weather and climate. See this jackknife here? It has a Phillips head and flathead screwdriver, scissors, a saw blade, a knife blade, all kinds of things. Comes in pretty handy when I'm fixing things around the house. But it can't build a house. There are so many pieces to building a house that no one single tool in existence can do them all. Every job requires a specific tool. I can combine a bunch of separate tools into one larger cool tool like this one, but it's still a bunch of separate tools, each designed to do a certain job a certain way. It's like that with weather and climate tools as well. Most satellite sensors record the amount of light or heat energy that reflects off of or is radiated from the surface of the land, the ocean, even off water droplets in the atmosphere, and they do this from up in space. Sensors on weather stations, buoys, and radiosondes need to be in close contact to what they're measuring. They have to be in the atmosphere or in the water to take measurements. Weather stations, buoys, satellites, and weather balloons, they're all multi-tools, combinations of separate tools, each designed to do a certain job in a certain way. You've just seen a very brief overview of the tools available for measuring and understanding weather and climate. I just barely got going. But the important thing to take away from this is you need the right tool for the job. Tools for measuring weather and climate have been around for over 100 years, and we continue to improve upon them. Who knows? Maybe someday you'll be one of the scientists using these tools to study climate. Or you might be one of the engineers who develops a tool we don't even know we need yet. There's something to think about. Well, that's it for this podcast. Until next time, enjoy exploring Earth systems. I'm going to go put my tools away and explore my options for supper. If you enjoyed this podcast, check out the others in our series by visiting mmsa.org/EASIE. The EaSiE project is a Maine Mathematics and Science Alliance initiative funded by the NOAA Environmental Literacy Program for K-12 education.